Hi, my name is Mark, and with this video I want to explain you a way to estimate velocity for impact motions using only encoder data and no model of the system. Consider this bouncing hammer. At every impact, an abrupt change in velocity is seen. In practice, the position and velocity are of course not known exactly, but are accessible through encoder data, for example. The noise in this data is amplified severely when you apply finite differencing. Quantization noise is usually filtered out using a low-pass filter, but when there are velocity jumps, the result is not really as you want. Standard low-pass filtering leads to inaccurate estimates near velocity jumps. The problem is caused by using the data before the jump to estimate velocity after, without considering an impact model. Note in this that the data before the jump and the data after are not correlated. This brings us to the first contribution of our work. We could use an adaptive window filter that resets whenever a velocity jump occurs. But how to detect the velocity jumps? We could of course use an additional sensor, but as I mentioned, we want a method that only requires encoder data. Instead, we could exploit the fact that acceleration is bounded for the smooth phases, but not during the jumps. This leads to the second contribution of our work, an algorithm that detects a jump whenever the difference between a prediction and measurement sample exceeds a parametric threshold. The combination of the filter and detection we call jump-aware filtering. Now let me now explain the principle using a part of the data we saw earlier. The data in the window is used for estimating, and to see if a velocity jump has happened, the data is extrapolated and compared to the current measurement. No velocity jump in this case. Let's fast forward to the jump. The threshold is now exceeded and the window is reset to just one sample. For the first couple of samples afterwards, the detection is turned off since it has too little information. Instead, the window is gradually expanded to regain the desired smoothing properties. And as you can see, the estimation accuracy near the velocity jump is now indeed much better. This was the approach in a nutshell. If you'd like to know more, check out the paper or just contact me. Thanks for watching.